Okay, so let's begin by opening up our Unreal project browser by launching Unreal Engine in the Epic Games launcher. So now what we want to do is select our project category. We're making a game, so we'll select Games, click Next. We're not going to use a template, so just keep that on blank, go Next. In terms of project settings, just make sure that you do have blueprints enabled here because we are going to be using the blueprint editor, visual scripting. And in terms of starter content, you can if you wish, but we aren't going to be using any starter content for this project, so you can create the project without any starter content like so. And finally, down at the bottom, choose a folder for your projects. I recommend having a dedicated folder for all your Unreal projects, and also then give your project a name. So here I'm just going to call this one Unreal Arcade Game. Okay, we can then hit Create Project and the editor should launch up. Okay, here we are inside of the Unreal Editor. You'll see that it automatically creates us a brand new level right here for us to use. So what we're going to do now is go down to the content browser and just set up our folder structure and import some assets that we'll be needing. So first of all, I'm going to click on this little button here at the top left corner to show the sources panel. So we can just see the folder hierarchy and easily navigate this way here. And inside the content browser, we're going to be creating 3 new folders. First of all, if we right click and select new folder, we can create a new folder here called levels. This is where we are going to be storing all of our levels for our game. Then we can create another folder here, right click, new folder, and this one is going to be called blueprints. And this is of course where we're going to be storing all of the blueprints for our game, the player, the UI, the game mode, the cars, the coins, all that stuff is going to be in that folder. And finally, we have another folder which is for the models. Now, the models for this game have been made inside of a program called Magic of Voxel. Magic of Voxel is a free voxel editor which you can just download online for free. This is what it looks like right here. You can create voxel art, you can create 3D models inside of this program. And if you have used this program before, I'm sure you know the tools, but of course there are many resources online explaining how to use this. If you do want to then export this to Unreal, what we can do is click on the export button down here and select OBJ. OBJ is an object file which is used in many different programs, Unreal for one of those. So we can just click OBJ and choose a location to save this to. Okay, so once that's saved to a certain location, you can then drag in the models like we're about to do right now. So we've got our folders here, now we need our models. Now you can download these from the included course files, the required assets that we'll be needing for this project. And if we open up our models folder here, we're going to open up the folder or the zip file that you can download from the course files, and this will include a folder called models inside of that. And inside of that you'll see a bunch of other folders here. Now make sure you do export this models folder before importing them to Unreal, otherwise there will be some problems there. So export the models folder to your computer, open it up, and then you'll see that we have a number of different folders right here. All I'm going to do is select these and drag them into the content browser like so. Okay, it'll pop up with some FBX import options right here, and all we want to do is just click import all. And here we go. You should have everything loaded up inside of the Unreal content browser now. We can go to each of the individual folders, have a look at their contents. They have their static mesh model, they have their texture, they have their material as well. So we can just drag this into the scene, scale it up a bit, and you can see that the model is there and working. Okay, so we're going to be working with these models all throughout the course. We'll be adding them to the blueprints, we'll be adding them to the world in order to build out our level. So now what we need to do is just save this level to our content browser. So we can do that with Control S or click Save Current at the top here. And we want to select the levels folder, and I'm going to call this one here our main level. Like so, it's now saved to the folder, and there we go. Now, finally, in setting up this project, what we're going to be doing is setting up our key inputs for the player. Because our player is going to be able to move forward, left, and right. So we just got 3 basic inputs that we need to be able to detect. So let's go ahead and open up the project settings window by going Edit, Project Settings, and inside the project settings window, we want to navigate over to the Input tab here on the left. Now in the input tab here, we have two things that we need to look at. We have action mappings and axis mappings. Now action mappings are basically when we press down a certain key, an event is going to be called, such as like jump, or in our case, move forward, left and right. Axis mappings, now we are going to be using axis mappings, but these basically take in a number of keys and you can sort of have this event trigger with a scale that can change depending on what keys are pressed. So we're going to be focusing on action mappings. Let's click on the plus to create a brand new one here. And this one is going to be called, if we just select the existing name and replace it with move_forward. There we go. If you hit enter, you'll see that we can now enter in a key value for this. So the key for this, I'm just going to use the W, A, and D keys for movement. You can, of course, choose whatever you wish for that, but I'm going to select it. I'm going to enter in W, and I'm going to find the W key here on the keyboard. There we go. So move forward is now an action mapping that is bound to the W key. We can then create another action mapping here. I'm going to call this one move_left. I'm going to bind this one to the A key. We can scroll down, find the A key here, and we're going to create one final one, and this is going to be move right. So move_right, and this one, of course, is going to be bound to the D key. D right here. There we go. And that's all the inputs we need to set up for our game. You can, of course, include more if you maybe want a menu that you can open up with the escape key or something. You can, of course, add those in right here. But we're just going to have these three basic key inputs. And that is pretty much it for the initial setup of the project here. Now, in the next lesson, we're going to begin creating our player controller. Setting up the player so we can move forward, left, right, and from there, creating the rest of the project. So I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to begin to create our player controller for our arcade game here. So what I'm going to do is go to our blueprints folder, which we created. If you don't have a blueprints folder, you can go ahead in the content browser, right click, select new folder, and create that right there. So inside of the blueprints folder, what we're going to be doing is creating a new blueprint. So it's a right click, go blueprint class, and this is going to be of type pawn, which is an actor that can be possessed and receive input from a controller, that controller being us, the player. Okay, so I'll select pawn here, and we want to give it a name of player. There we go. We can then double click to open this blueprint up inside of the blueprint editor right here. I'm just going to dock this window to the main window here. And now what we're going to be doing is setting up our components. Now our player is going to have a few components. They're going to be having the 3D model, which is going to be what we can see. They're going to have the collider, and then we are going to have the camera, which is going to be at an offset from the player, so the camera tracks them from above. Okay, so let's start with our player object. First of all, we want to add component, static mesh. There we go. And we can call this one our player model. Then down in the details panel, we want to set the static mesh here to be, if we can find it here in the list, player. Okay. Now, we can't see it right now because in Magic of Voxel, the default parameters for like the scale are very, very small. So what I'm going to be doing is changing the scale here of this static mesh to be 50 by 50 by 50. And there we go. We can see the player model right there, but they're not positioned or rotated correctly either. So what we're going to do is set the location on the X to be 50, the Y to be 50, and the Z to be -50. Okay, now it's still not positioned right, so we need to rotate it so it is right in the center. And to do that, we can give it an X rotation of 90, a Y of 0, and a Z rotation of -90. And there we go. We got our player right here, pretty much standing on top of the default scene root, which is what we want. And now what we can do is go ahead and actually also in the details panel, go down to where we have collision. Now, we're not going to be detecting collisions with the player model. We're going to be having a separate component for that. So let's make the collision presets here, instead of being block all dynamic, we're going to make it no collision, which basically means that we aren't going to be colliding with anything. Okay, now we can go ahead and create our collider for our player. So what I'm going to do is I'm going to add component. We're going to look for capsule collision right here. And this capsule collider, what we're going to do is, by default, it is very large, as you can see. So what we're going to be doing is actually bringing this down in size. So here we have the capsule half height. We're going to set this to 0.5. The capsule radius, we're going to set to 0.2. Make sure to reset that back to 0.5 if it does change. And now we can position it. So I'm going to be setting the rotation on the X to be 90, so it is vertical like so. And the position is going to be 1 on the X, it's going to be negative 1.6 on the Y, and negative 1 on the Z. And as you can see here, the collider is a bit smaller than the player, and the reason why is to just give that player that little bit of extra wiggle room in order to dodge obstacles that come towards them. Okay, so down here in Details panel, what we want to do is go to the collision area here, and what we're going to be doing is going down to collision presets and setting this to be trigger. Okay, there we go. And apart from this, that is the collider set up and ready to go. Now what we can do is go ahead and create our camera. So for the camera, what we want to do is what we're going to do is go add component. Let's look for camera here. There we go. And what we want to do is select that component, and in the details panel, we want to position it so it is above the player looking downwards. Now, you can of course position this wherever you want, but I'm going to position this in a specific point at negative 200 on the X, 220 on the Y, and 820 on the Z. So you can see the camera's up here at the sort of top corner of the player, so it's going to be looking down at an angle to the player. So for the rotation, we're going to be setting the Y to be negative 65 on the Y and negative 40 on the Z. Okay, so you can see here the camera's down looking at the player. And along with this, let's change the field of view to be 50 so that it's a bit more of a shallow field of view and we have a much finer focus on the player. Okay, so that is it for setting up our camera, and that is it for setting up our actual player components. We've got all that set up now. So what we can do now is go back to our level and place our player in there, set up the game mode, and just see if it works. Okay, so I'm going to hit save, I'm going to hit compile. Back inside of our main level, what we want to do here is go to our blueprints folder, and in order for the game to know that this player blueprint is going to be, well, the player, what we need to do is create a new blueprint here of type game mode base. I'm going to call this one my game mode. And this just defines some basic things such as what is the default player and any other defaults that you might have. Okay, so we're going to open up the My Game Mode blueprint here. And on the right hand side, you'll see there are a bunch of classes that we can choose. We have Game Session class, Game State class, but what we want to look at is the default pawn class right here. Right now it's set to the default pawn. We don't want that, we want it to be our player. So we can select our player object right here, our player blueprint. And that's pretty much all we have to do. We can then click compile, click save, we can then exit out of this tab right here. And back inside the main level, we want to go over to our details panel, and you'll see that there is a world settings tab. This world settings basically defines properties for this level, including the game mode override right here. We want to select none and choose my game mode. So now this level here at the start is going to read this My Game Mode blueprint, and it's going to see, okay, the default player is this player blueprint down here, so we'll make sure that the player controls this object and we'll spawn it in for them. Okay, so if we now press play, you'll see that the player spawns in and we have the camera looking down at them. Okay, but we don't have any of the movements set up yet, we don't have any of that. So in the next lesson, we're going to be working on setting up player movement. We're also going to be setting up setting the initial player position, because as you can see, if we go Shift F1 to get the mouse cursor visible and click the eject button here, you can see we can fly around while the scene is still playing, that the player is sort of just hovering in the air right here. And the reason why is because if we click stop, you'll see that we have this player start object right here, which basically defines where the player is going to spawn in the world. Now the player is going to spawn in this center position right here, which is around 1 meter off the ground. So what we could do is we could drag this down here to floor level, press play, and you can see now that our player is standing on the ground, okay, which is good. And you might see that it also says bad size here, but we don't really need to worry about that. That's mainly just saying that because the capsule here is colliding with the ground, but we don't really need to worry about fitting the bounds of that. We just want to know the single point in space where we need to spawn our player. So there we go. We've got the camera set up, we've got our player component set up. Now in the next lesson, like I said, we're going to be starting with actually constructing the logic for moving our player around. So see you all then. Welcome back everyone. In the previous lesson, we set up our player blueprint. We set up the components, we set up the camera, we placed them in the world here in our main level, and set up the game mode blueprint as well. So in this lesson, what we're going to be doing is starting to actually construct the logic for us to be able to move around. So let's go to our player blueprint here. Let's go to the event graph. And what we're going to do first of all is set up some variables that we'll be needing. So the first variable that we'll be needing is going to be a boolean, which is going to be called canMove. Now I'll explain these in just a second. And we'll need another variable, which is going to be called targetPos for target position. And this is going to be of type vector. We can change that here in the details panel. Okay, so we got these two variables. Now the way we're going to use them is by actually setting our target position to be wherever we want to go. Because the way this is going to work is whenever we press a key such as W to go forward, what we're going to do is first of all see, okay, is this canMove variable true? If this canMove variable is true, then we are going to set our target position here to be basically 100 centimeters or 1 meter ahead of us. And then what we're going to be doing is every single frame, we're going to be trying to move towards this target position. Now, the reason why we need a canMove variable is because we don't want the player to be able to spam W and just keep moving forward as fast as they can spam W. We want the player to be moving forward at a set pace or moving left at a set pace. We only want them to be able to move once they have reached the next position. Okay, so what we need to do first of all is set up in our event graph here a function called tryMove. And this is going to be called whenever we detect a key input from the A, W, or D key. So let's go ahead, create a brand new function right here. And this function is going to be called tryMove. Now there's going to be one input that we're going to be having with this function. And this input here is going to be called the direction. It's going to be a vector as well because this is going to be the direction that we're going to be moving in. And what we need to do first of all is basically check to see if canMove is true. So we can put this out into a branch node here. The condition can be get canMove. So if we can move, then what we're going to be doing is setting the target position. So we can drag this out into a set target pos node right here. And the target position to set is going to be our current target position plus the direction. So I'm going to drag in target position here, get target pos, and then from direction, I'm going to put this into an add node, a vector plus vector node here, plug target pos in as well, and there we go. We can then plug this into the set target position node, and now our target pos is going to be our current target pos plus the direction we want to move in, which is also going to have the length as well, which is going to be around 100 units. Okay. So afterwards, what we want to do then is set canMove to false. So we'll go set canMove, make sure that is disabled as false. So basically, if we were to press the W key, it's going to call the tryMove function, sending over a forward direction. It's going to see, okay, can we currently move? Let's just say it's yes. Then we're going to set our target position to be our current target position plus the forward direction. And then we're going to set canMove to false. Okay. Now, once we set to false, we need to wait a certain amount of time before setting it to true again. And to do that, we are going to create a new node here called setTimerByFunctionName. What this does is it basically is a delayed function call. So like we would normally call a function by connecting to a node, this node right here basically calls a function name, we can enter it here, with a delayed time. So this function that we're going to be calling, we can create it right here, is going to be called enableCanMove. And it's going to do just as it says. It's going to basically enable the canMove variable. So it's drag and canMove, set canMove, plug that in, and enable the canMove variable like so. And that's all this function is going to be doing, okay? So we can save that, we can close the function. Now in the tryMove function, what we're going to do is set this node's function name to be enable can move. Make sure you have the right spelling. And we're going to set the time here, so the time delay, to 0.3 seconds. So every 0.3 seconds, we will be able to basically move again. And this just prevents us from being able to spam keys and moving all around the place. We only want to be able to move once the player has reached their target position. Okay, so we've got this function here set up. Now, back inside of the event graph, the main event graph, what we're going to be doing is, first of all, we can actually delete all these nodes here since we don't need them just yet. And we're going to right click and we're going to look for a move underscore forward action event right here. And this gets called once we press down on the W key. And when it presses down, so we'll drag out from the pressed output execution here. We'll plug this into a try move function. And all we need to do with this is give it a direction. Now, if you remember, the X axis is classified as the forward direction in Unreal here. So we're going to give the X here 100 units, Y0 and Z0. So as well as this, we also want to create the move underscore left input action right here. Connect that to a try move function. And the direction for this is going to be negative 100 on the Y. And finally, we want to create a move underscore right, which is going to be also connected to try move function with a positive 100 on the Y, which is the right axis. Okay, so we got that set up right here. Now, if you press play, you'll see that nothing actually happens. We can press play right now. Nothing happens when we press our keys, and that's because we are setting our target position, although we are not currently moving towards it. So in order to actually move towards our target position, what we need to do is every single frame move towards it. Okay, so we'll right click here. We want to create the event tick node, which triggers every single frame. And we need to plug this into a move component to node. This is a very powerful node, which basically allows us to move one of our components towards a certain position over time. Okay, so the component that we're going to be moving is going to be our default scene root, the most base component in our list. And this is going to be moving to a target relative location of our target pos right here. Okay, and over time is basically the duration it's going to take, 0.2 seconds. That's fine, we can keep it like so. So if we compile, save, press play, you'll see that when we press W, we don't do anything. And the reason why is because we actually have to set the default value of can move to be true. So we'll set the can move variable, set that to be true at the start, otherwise it'll never be able to go through that loop. So once it's enabled, we can hit compile again, save, press play, and you'll see when we press W, we move forward 1 unit, we can move left, we can move right, and you can see if you spam a certain key, it's not as if you keep jumping between it rapidly. You always wait until you get to that position before moving again. And when I let go, it stops moving basically instantly up until the next move. Okay, so that's what we want. We can move forward, we can move left, we can move right, forward again. Okay, so there we go. That's pretty much what we wanted to do. So let's just go over what we've done so far again. We set up our input actions right here, which get triggered once we press either the W key, the A key, or the D key. And these call the try move function. And inside the try move function, it takes in a direction we want to move in. And it basically, first of all, checks, okay, are we able to move? If so, set our target position to be our current target position plus a direction, and then disable can move. Yet after 0.3 seconds, re-enable the can move variable, so we can't rapidly move in a certain direction. Then in the event graph, what we're doing is every single frame we are moving towards our target position in 0.2 seconds, which gives us the corresponding movement like so. Okay, so in the next lesson, we are going to be setting up some of our obstacles, such as the cars, and then later on setting up our goals, such as the end flag and the coins. So I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be setting up our obstacle that the player needs to avoid, which is going to be a car. You can, of course, make this whatever sort of object you want, but for our game, this is going to be a game where the player has to sort of cross the road, so we're going to have cars that are going to be moving left and right that the player has to avoid. So inside of our blueprints folder, what we're going to do first of all is right click, create a new blueprint class, and this is going to be of type actor, which is basically an object that isn't controlled by a player or anything like that. So we can select actor, and I'm going to call this one car. Okay, we can double click to open this up inside of the blueprint editor right here. And what we're going to do first of all is add in our static mesh. So static mesh right here, like so. And this static mesh is going to be, if we go to the details panel, we can set this to be the car. Now again, just like with our player, this is a very small model, so we need to increase the scale here to be 50 by 50 by 50. The rotation and location need to be changed as well, so the rotation is going to be 90 on the X and 180 on the Z. You can see it's up there, so we need to bring it lower down and a bit more to the right. So we're going to be setting the X location to be 75, the Y to be negative 37, and the Z to be negative 100. Okay, so there we go. We've got our car. It is sitting on the ground like so. Let's also go ahead and disable some of the collisions since we aren't going to be detecting collisions through here. So we can go down. Let's disable generate overlap events and change the collision presets to no collision. Okay, there we go. Now what we need to do is set up our actual collider, because we don't want the collider to be based off the model, because it's quite large, and just like with our player, how we made their collider smaller than their actual model, this is so that when a car's coming and the player just avoids it, it doesn't accidentally clip a little bit, which doesn't really appear to be connected. It just adds some leeway in there when trying to avoid these obstacles. So we'll go add component. We want to look for a box collision right here. Now by default, this box collision is very large, so we are going to go to where it says box extents, and we're going to change this to 1.3 on the X. It's going to be 0.45 on the Y and 0.6 on the Z. We then need to reposition it, so we'll set the X location here to be 1.5, the Y to be negative 2.5, and the Z to be negative 0.7. There you go. You can see the box is now over our car right here. All we need to do now is go down to the collision. Make sure generate overlap events is enabled and set the collision presets to be trigger. Okay, so that we can go through the player and trigger that collision. So now that we've got that set up, what we can do is go to the event graph and actually create the logic for moving the car. Now the way this car is going to move is it's going to be having a starting position that we'll give it, and this starting position will then have a distance that it is going to move along. So the car is going to be moving along their forward direction. Now once it reaches the distance away from start position, it's going to reset back at that start position, move along their forward direction, and once that distance is met again, it is going to reset. So it's going to keep going, resetting its position, going, resetting its position. Okay, it'll be a bit easier to understand once we set this all up. So what I'm going to do is I'm going to delete the begin play and begin actor begin overlap nodes. So we just have the event tick right here. And we are going to be plugging this into an add actor world offset node, which basically adds a location to our existing one. And this location that we're going to be adding is going to be our forward direction multiplied by our speed. So let's go ahead and create some variables right now. So we have our speed, our start position, and our distance. So the first variable here is going to be our start position. This is going to be of type vector right here. And also we want to make this instance editable so that we can change it as we drag the blueprint in, so different cars can have different start positions. The next variable is going to be our speed, which is going to be of type float. And this also is going to be instance editable. And finally, the last variable, which is going to be distance, also of type float and also instance editable. Okay, we can compile to basically set those variables in. And now what we can do is work on this add actor world offset node. So this node right here, it's going to be taking in the speed. So we can drag the speed in here, get speed. And we want to basically multiply this. So we can put it inside of a multiply node, multiply float by vector, and the vector we're multiplying by is going to be our forward vector. So we can go get forward vector of the default scene route right here, and this is going to get our speed multiplied by that. We can then plug this into delta location. But the problem with this is that it is now tied to our frame rate. So the faster our frame rate is, the faster this object's going to move, because we are moving at whatever the speed is per frame rather than per second, which is what we want. So in order to make it per second rather than per frame, let's delete the connection between speed and the multiply node, and instead multiply speed by delta seconds. So we'll put this inside of a multiply node here, float by float. Multiply speed by delta seconds, which is basically the duration between two frames. This is a very small number, and if we multiply it by a value, it will convert it from a per frame to per second time frame. We can then plug this into the multiply node, and now our car is going to be moving in its forward direction at whatever the speed is per second. Okay, so we've got that set up. Now what we can do is make it so that once we actually reach a certain distance away from the start position, we can reset to the start position. Okay, so at the end of the add actor world offset node, we're going to plug this into a branch node. And the condition for this branch node is going to be whether or not the distance between our current location and the start position is greater than distance. So what I'm going to do is create a distance node, so distance 2, and this is distance in brackets vector. And this takes in two vectors and calculates the distance between them. So the first vector here is going to be our get actor location, and the second vector is going to be the start position. There we go. Okay, so we got those two. Now what we need to do is just check to see if this is greater than speed. So we'll plug this into a greater than node and make the second input be the distance. Get distance. There we go. Okay, so if our distance between our current position and our start position is greater than our distance variable, we'll plug that into the branch node. So if that condition is true, then we are going to set the actor location, so set actor location to be the start position, just like that. And that's pretty much all the logic there for moving our car. So again, what we're doing, every frame we are calling the add actor world offset node, which basically adds a vector to our existing location, this vector being our forward direction multiplied by our speed per second. And every frame we're also then checking to see if the distance between us and our start position is greater than the distance variable. If that's the case, then we are going to be setting our location back to our start position, so we keep on going in a loop. Once we get a certain distance away, we reset. Okay, so let's go to the main level now. Make sure to compile, save. Back in the main level, we can drag the car in. We can rotate them. Press E to get the rotate gizmo. Rotate them around like so. Press W to get the move gizmo. We can move them over here. And let's set it up so they move right across the screen. So I'm going to go back to the details panel here. I'm going to set the start position to be 330 by negative 420 by 20, which is our existing location. The speed, we can set this to be about 5, and the distance, if we drag it over here, you'll see that the distance is basically negative 450 to 450, so that's about 1,000. So 1,000 on the distance here. And now if we press play, you'll see that the car is moving very slow, and that's because I set the speed to be a very slow number. This is moving 5 centimeters a second. So what we want to do is move 5 meters a second. So we need to make this number 500 actually. Okay, hit play, and there we go. You can see the car's moving. Once it reaches the 1,000 unit distance, it gets reset back to the start position. Okay, so we got the car set up. Now what we need to do is make it detect when it is hitting the player, and we're going to be working on that as well as the other conditions in the next lesson. So I'll see you all then. Welcome back everyone. In this lesson, we're going to be setting it up so that when the player collides with the car, it's basically game over. Now, later on in the course, we're going to be setting up some UI that is going to appear telling the player that the game is over, that they can restart or quit the game. But for now, we're going to make it so that when the player hits the car, the level is going to restart. Okay, so over in our player blueprint, what we want to do is, first of all, create a new function here called game over, and this game over function is going to be called when the player hits the car. So what we want to do in here is just restart the current level right now. Okay, so we're going to drag out from here. Now to start off, we need to get the current level name so we know what level to open up. So we go get current level name. We can then plug this here into an open level node like so. And you can see that the get current level name has an output and open level has an input. We just want to connect those two like so. It converts it from a name to a string, or a string to a name here. And that is how we can restart the current level. All right, so we'll compile that. Now over in the car blueprint, we want to detect collisions with the player, or detect overlaps with the player. Now in order to do that, we are going to be using the actor begin overlap event node. So we can go actor begin overlap right here. This is going to get called whenever a collider overlaps the car's collider. And we want to check whether or not the overlapping actor is a player, because we don't want to have the game over state whenever anything collides with the car, in case it collides with a coin, in case it clips with the ground. We only want the game over function to be called when the car collides with a player. So to do that, we can cast this other actor, which is basically whatever object is colliding with us. We can cast this to a player. And that basically means converting this object to a player object, and that can either succeed or it can fail. So we're going to plug this into a cast to player node here, plug in the other actor. Now, if we were successful in casting it to a player, this is what's going to be executed. Otherwise, cast fail will be executed. So if it did succeed, then we want to call the player's game over function like so. Make sure to plug in the player as the target, and that's pretty much it. Just these three nodes in order to detect collisions, check to see if it's the player, and then call their function. So I'm going to compile that, save the blueprint, and then press play. Now, if we move up to the car, you'll see that when we get hit by it, we can't actually get hit by it right now because it just seems to avoid us. So what we're going to be doing, get in the car, we'll move it down a bit here in the center, press play. Now, if we move along this line, you'll see that there we go. We got hit and the level reset. There we go. Okay, so it's working. We've got that all set up. Let's try and narrowly avoid it. There we go. We can. And yep, that's basically setting up the player's death state, the game over state. Now that we have that set up, what we can do is introduce some coins so that we actually have something to aim for as the player is moving along the ground. Okay, so in the next lesson, we'll be working on the coins. We'll be working on setting up a player score so it can increase over time, and then later setting up a UI so that we can see that while we're playing the game. So I'll see you all then in the next lesson.